YouTubers and say Happy Garbage Day. We have Erica here to guide us through formative assessment number 2, which is being captured. So yeah, you can watch the little green bar that proves it's recording.
Okay, great.
Yeah.
Trying to make sure. There we go. Okay. So, thank you all for your answers. Yes, sorry.
You gotta project, dude.
Okay. So, going over question 1, the first question was, in a 2-level model for persons nested in clusters, what is the purpose of level 2 predictors and what is the purpose of level 1 predictors? And then what kind of variance should each kind of predictor explain? So, anyone want to answer level 1, level 2?
Well, level 2 predictors are used to more accurately reflect where the variance in your data comes from. Like it's coming from some higher level cluster difference that you wouldn't account for at just level 1.
Mm-hmm. And so what would you say that the level 2 predicts, the predictors? Or explains?
Between group differences.
Yeah, so random intercept variance,
Yeah.
Yes. And then does anyone want to talk about the level 1 predictors?
Well, I'm trying to understand with the perspective of intra and then inter, right? So intra is level 1, and I try to understand inter as level 2, and let alone talk about more details.
Yeah, those synonyms are always hard for me. I have to do the weird hand motion of inter and then intra to
Yes, yeah.
Because that's the only way I can remember
We
it.
can add that to our list of pictures. Of course.
Yeah. So being inter, what kind of characteristic?
This is intra.
Intra, what kind of characteristic would it be? If we're thinking of clusters, what would be nested in clusters?
Yeah, so I was wondering if I can have classes which is nested in the schools.
Yeah.
Right?
Yeah.
So that could be inter.
Yeah, that would be an example.
Right.
And then what would a predictor, a level 1 predictor, what kind of variance would that explain?
Explain both variance in level 1 and level 2.
Yeah, so it depends how it's centered, which exactly it's going to explain, because the level 1 predictor has both the level 1 and level 2 parts of it, yeah. So I just have pretty much the same things that you all said. So level 1 within, person things, always easier for me to remember. Residual variance, level 2 is going to be either between or contextual based off of the centering, and then their cluster things, and it's going to be explaining the random intercept variance. So then going into the different types of centering, when you're using cluster mean centering or variable centering, for a level 1 predictor, how does one interpret its fixed effects? So just thinking of just a level 1 predictor, cluster mean centered, how would that be interpreted? Or if anyone wants to explain what cluster mean centering means.
Yeah, that'd be a good place to start.
I wrote this, but I'm not sure if I'm right. I said that the fixed effects of the within cluster predictor represent how much individuals outcomes differs.
Within the cluster, yes, yeah. Anyone want to add to that? Michael looked like you were going to say something.
That's what I was going to say. Is you did a great job. I don't need to expand upon it.
Okay, yeah. So the important part of just being within whatever clustering, nesting structure it is. So people within clusters, and then how would you interpret the fixed effect of the level 2 cluster mean of the predictor when cluster mean centering?
Interpret it as the difference of a cluster being a unit higher or lower than the mean value of the
Yeah, so it's cluster mean.
It's different compared to other clusters.
Yes.
Yeah.
Yeah, exactly. And then how would the interpretations change, or would they, if you're including one but not the other? So you just have within, and you just have between, and you're putting either only the within-centered version or only the cluster-centered version. Would there be a change or not in the interpretation? And if you don't know, you can say something.
Yeah, I saw a bit of confusion on this question, so
Yeah.
I think it'd be good to spend some time unpacking it.
Yep, okay. So yeah, fixed effect slopes. All of you were great in, thinking about it as the 1 unit change of a slope. So that stays the same, obviously, with no matter what the centering is, it's just of what. So the within is going to be of people within their cluster, and then the level 2 is going to be from cluster to cluster. And then the easiest thing for me to remember personally when I'm thinking about cluster mean centering is that you make them orthogonal, which is like the stats term for just separating them to be completely separate.
Uncorrelated.
Uncorrelated, yes. So you're taking out that cluster mean from the within part, so you just have the within that's left over, removed from any of that cluster mean variation, and then the cluster mean is on its own. So you don't have to control for it. They're each partitioned into their own separate parts. I know Lisa will talk about it sometimes as like they stay in their own lanes.
I do say that.
Yeah, and so like you think of it like they're not affecting each other. So if you just put within in the model only, you're only going to get within. And if you just put the cluster mean in, you're only going to get between. And then if you add both, you're going to get both within and between. But they are not impacting each other. If that makes sense.
Can I throw in a bonus question?
Yeah.
Do you have to worry about a smushed effect if you use cluster mean centering? Yes or no?
No.
No. So why is that, folks?
Yeah, what she said, it partitions the means.
They stay apart, yeah.
Yeah, you solve the problem preemptively in how you set up the variables. Is the way I would say it.
Or like how you've said, you're doing the work first instead of making the model do the work. And then going on to the next question about grand mean centering. So if you're grand mean centering or constant centering for a level 1 predictor, how would you interpret the fixed effect when only including the level 1 predictor? So I would first ask, what is in a level 1 predictor generally?
Everything.
Yeah, everything. And so when you're grand mean centering, what is in a level 1 predictor?
It's still everything. All you did was shift it over somewhere.
Yeah, so the level 1 predictor still has within and between, and so the vocab word, what would it be?
Smush.
Yeah, smush. And so how would it change the smushed effect once you add the level 2 cluster mean into the model?
I think level 2 cluster mean, when you add that, it allows you to interpret a contextual effect.
Yep.
Yay!
More on that today, by the way.
Thank you.
If you're thinking about, I don't know, Lisa's like 2 lanes smushed, if it's smushed and then you add the cluster mean, it's going to push it over and unsmush it, because then the model is going to control for the cluster mean part. Do you like
I
my
just-
gestures?
Yeah, you just gave me an idea for an analogy. Can I do it?
Yeah.
Yes.
Okay, so when Hugh was like 4 years old when we first moved here, we used to go to the mall to just hang out, like go to the Children's Museum. And at the time, they had these riding animals that you could pay like $10 and they're electric, and you just ride around the mall. You know what I'm talking about? Like horses and lions and shit.
Yeah.
So he's not a great driver at 4, as you might imagine. So I used to have to ride on the back of this thing with him and help him steer. And so you picture like the
That's a
smushed
smushed
effect
effect.
is him just, all over the place, running into people and walls. And then the mommy contextual effect has to hop on and like oversteer and keep us from running into things. So then the car drives like it's supposed to, with a little help from level 2. Does that work?
Yes. Yay!
Oh, I get applause for that. No, the worst was when he rammed me into a wall and I couldn't get off the wall, so my leg is like.
Oh.
So we went to the mall to get him some new clothes. He's 10, by the way. He's this tall. All right, and he's like, oh, they have them again. Can I ride them? I'm like, dude, no. Although I bet he's much better at driving by now. But we're not going to find out. 'Cause he's not riding a toddler toy at age 10. On the
Time
mall.
for the go-kart.
He loves go-karts. Yes, we're gonna check out the go-kart scene. So that's it. He is very, very tall. Yes, for his age, 97th percentile.
Wow.
So that's not my doing, obviously. That's John.
Okay, so thinking of it being a contextual effect then, how would you interpret it? There's a couple of ways. Some are easier than other, or even just thinking about how contextual effect relates to within and between. I know we only briefly talked about this.
Well, it basically says when you're here, moves you over to your appropriate cluster spot. That's all you're just saying, okay, I need to go here or I need to go there, wherever I need to go off of the center versus starting out at the center of your cluster, which is easier in my opinion.
Yeah, it's easier to not mess up when you're cluster mean centering for sure. So personally, when I think about like contextual effects, I think of like literally the word context because it's the context. You know, sometimes in stats we actually have words that make sense.
Occasionally.
Yeah, so this is one of them. We're thinking about the context of what the level 1 unit is in. So the easier one that I think to interpret is like when you take someone, an individual person from their cluster and move them to the other cluster, so that difference between moving between clusters, but it's the same person. Or if you think about it as the test for whether or not like you need two slopes, because within and between is contextual, or between minus within is contextual. Yes. So within minus between is contextual is always
Other way around.
oh my gosh. Yeah.
Now you know why I close my eyes when I talk.
No, that's yeah.
It's hard.
Within minus between is between
No.
minus within. Yeah.
Between minus within.
Okay. Because level 2 minus level 1.
Yes.
Yeah, okay. See? Even I can mess it up, yeah. And then the other interpretation is controlling for the level 1 effect, so the person. So you're looking at the level 2 clusters, but you're controlling for person characteristics. That's why you're letting the model do the controlling instead of like the centering that we do in cluster mean centering of like doing the work up front. Whereas with grand mean centering, we're letting the model do the work, and that's controlling for the person characteristics. Let me see, so level 1 only, level 1 in cluster mean. So level 1 only is going to be a swished effect. Level 1 in cluster mean, you're going to get within it contextual. And then the next question, so assuming level 1 variable is related to the target outcome, describe what can happen to the level 2 random intercept variance when only adding a predictor that has been cluster mean centered. So we talked about what is in a level 1 variable, so what is in a level 1 variable after cluster mean centering.
Just within variance.
Within variance, yeah. So, and that is going to explain the residual variance. And then, so what happens to the random intercept variance, because I know this one is a trickier one, is that once the residual variance is explained, the model has to adjust and rescale the variances, and now the random intercept variance is actually going to go up a little bit, which is weird, but it just adjusts a little bit just to take into account that the residual variance is being explained, even when, so it's not going down. That's the big thing, is like you're not explaining the random intercept variance when you have a within only cluster mean centered level 1 predictor. It's not explaining it because you only have the level 1 within part in it, so it can only explain the residual variance. Whereas when we're looking at constant centered, or grand mean centered, it's going to have both. So what's going to happen to the random intercept variance? It's going to go up or down.
Decrease?
Yeah, because we're explaining it then. So yeah. So then in that case, they would both go down.
Yeah, I'd say that's the most likely outcome. Occasionally, you might see something weird happen if the smushed effect is really, really wrong.
Yeah.
Then it's sort of a change, but in practice, this is what happens.
Constant centered contains both, so it's going to decrease both. And yeah, you got the weird special case of random intercept going up when cluster mean centered within is added. So then for the next one, when reading a results section for multi-level analysis, what are two indicators, or just any indicators, of a smushed version of a level 1 slope?
They didn't really do multi-level. They just had that's a single level.
So like thinking if like they explain their sample or like people and they say like there's clusters but they don't do anything, they just do a single level. Yeah. Anything else?
Let me look at my answer. Maybe I have something else.
Now the slope has both level 1 and level 2 effects because of smoosh effects, right?
Mm-hmm. Yeah, so if it's only one slope, then it's going to be smushed and not having the corresponding cluster mean. They usually just throw in the level 1 as is. Anything else? Has anyone seen it in practice? I know Lisa mentioned there's a lot of examples out there of messed up multi-level. Say thinking about like the ICCs. Like personally, yeah.
Like if they report their ICC and it's above 0, but then they don't do a cluster or like a level 2, if they don't add a slope to account for that?
Yeah, like they say, hey, there's some dependency in the data due to clustering, but that's it, that's all they do, then yeah, they're not going to be actually handling that and unsmushing it. So not adding a second slope, only doing single level, and not mentioning that, not addressing the clustering, nesting, ICCs. I also see sometimes of like, they won't do ICCs, whereas like, I think it's pretty common to like, say like for a level 1 predictor, like this is the ICC, and then do it. So like if they have a level 1 predictor and don't report the ICCs, you can think about that, like, well, why didn't you do that? Because that's helpful to see whether or not you need to unsmush it later. Yeah, so only one slope for the level 1 predictor, not including cluster mean, no centering talking at all. Like usually because there's the different types of centering, they will say that they did centering. Sometimes they can also do it wrong, which is harder. Is like they'll mention like they centered, but then you look at it and you realize it wasn't centered correctly. Yeah.
I would also add effect size to this list in terms of variance explained.
Okay. Yeah.
So level 1 predictors are supposed to explain level 1 variance, but if they explain level 2 and there's no level 2 version of it in the model, that's a smushed effect.
Mm-hmm.
Trojan horse.
Yes. Yes.
So let's say, so, like when we do homework, we know like, so we can check if it's right for like if we center right, check. But then when we're analyzing our own data in the future, how do we know our model is correct?
You don't.
What do we do? Just
Would you like to take this one?
Yeah, I mean, when I'm doing it and well, the obvious thing is I have Lisa to go and double check after I do stuff. But when I'm doing it myself, like I'll look at the data, like hopefully you would know something about the data, you know, it's not just like some random data that you've gotten, but you're looking at it and like thinking about the levels in it, the nesting structure, doing things like computing descriptives, ICCs, and then trying to center it like the best way. That's where you get into like some of the hybrid models of like sometimes when you have categorical predictors, you get into the weird thing of like do you want to cluster mean center? Do you want to grand mean center? And so like thinking of those decisions and yeah, hoping for the best, asking for reviewing, I mean checking like if you're adding one predictor at a time or like one part of it, seeing how the variances are changing, like if it's explaining the right thing or not, like, you know, if you add a level 1 predictor in that you think is centered and then, it explains random into some variance and it's like, okay, I messed something up here, something went wrong.
Yeah, I'd say you could also run correlations of the within cluster version and
Yeah.
between cluster version, and it should be 0. But if it's not, something went awry with your centering, probably due to missing data in that case.
The joys of missing data.
Don't have any, that's the solution.
Yeah, very practical.
Yeah, Vladimir, did you want to weigh in on any strategies? How do you know that you're not screwing up in practice?
I do something similar, but I'm lazy, so
You keep saying that, and we're not buying it.
I don't
dude.
believe it.
None of us believes this.
TA cannot say that.
most of the time I check my predictors with all the variables that we have, and I try to choose those that make sense and are related to my research question or research hypothesis. So I try to narrow the focus or scope of what I'm doing, and then I just make a decision about clustering centering or constant centering depending on what we are interested in. And then I just run like the full model after running the empty model for the predictors and have an idea about what the ICC is. But most of the time I just check that ICC for predictors is more than 0.01 for instance. That's enough to me because we are not focused on the systematic variance of the predictor, but the outcome. And then I just focus on my full model because most of the time I have something in mind about the relationship between my predictors and the outcome. And then I make decisions about the statistical significance, and then I focus on the contribution of each predictor in the model in terms of the pseudo R square or fake sizes for the slopes. And most of the time that's what I do. That's all. Pretty straightforward. Problem now is missing data. To me these days missing data is a huge thing in research.
Why you pick 0.1 axis?
Oh no. I'm not choosing, I'm just looking that ICC is more than 0.01 because that means that we have something at level 2. But in practice, it doesn't make sense if it doesn't make a difference if one of your predictors is ICC 0.2, 3 or 4 because what we are doing is the same in any of those cases, unfortunately. Because here we are manually partitioning that. So let's say that your level 1 for students within clusters has an ICC of 0.2. That's not different in practical terms to an ICC of 0.4 because in both cases you are using clustering centering or constant centering. So that's what I do. I just want to check that I have something at level 2. And I have not seen nothing. I have not seen level 1 predictors with an ICC equal 0 or close to 0. Most of the time I've seen 0.2, 0.25, 0.3 in my research at least, my field.
Because you can get those really low ones, but you still have to treat it the same way.
Yes, exactly. Yeah.
Okay, and then the last one, if anyone would like to share any examples or just give some ideas of what your research area is so we could come up with them.
What is research?
I know Robert had a good one.
Yeah.
I'm calling on it for you.
So my main leadership areas or research area is leadership. And so an example could be looking at employees' levels of their commitment to their organization. So level 1 would just be between employees, the difference in their levels of commitment to organization, not taking into account the leader they work for. Between would be the differences between like leaders clusters and their like mean organizational commitment, so between leaders. Then contextual would be the variance, like accounting for the smush slope, like the additional variance accounted for by like the leader cluster, like beyond just individual differences in the organizational commitment.
Yeah, that's great. Thank you.
Imagine context is a big deal over in your world.
Yeah.
That's some other good ones. I just remembered that one because it was a different story than kids in classes.
Yeah.
I'm a teacher, what can I say? And you talk about teaching
You're
already.
allowed to have kids in classes. It's the College of Education.
And selling a teacher, Hawkeye teacher on the screen.
The Hawkeye teachers?
Yeah, makes like guy scan the QR code. Hawkeye teacher.
Okay,
Oh, he's a huge teacher.
that's right. Teachers everywhere.
Mhm.
Yeah, you have the obvious education, students in schools. So you can think of reading, math, any sort of achievement outcome, social, emotional learning. You also think of like those predictors and then splitting them up within students, looking at the students within a school or whatever cluster unit, and then between schools, the contextual, the difference of moving between a different school or
I even want to look at instructors. I mean, if I get a role that I'm potentially thinking of, I was like, okay, I want this instructor teaching this class because they do better than this other person, period. Because you want to put your resources where they work best. And so the cluster would be the students, but then that second level would be the instructor.
So students in some sections might do better based on who their instructor is,
Mm-hmm.
even after controlling for their own whatever.
Uh-huh.
Hypothetically speaking.
And I have more control than like here because our classes are pre-made, so to speak. So my class would be the same as your class, would be the same as Lisa's class. If we were teaching, the only difference is our style of how we interact. That's it. Everybody has the same quiz, test, homework.
That's a really controlled environment.
That's what I'm saying. So so if there's a difference, it is almost 100% the instructor.
Okay.
less level 2 predictors to add, yeah.
Mm-hmm.
Can I throw in something different first?
Please.
Yeah.
Please.
So my research area is anti-immigrant sentiments in countries, and I was thinking maybe the ripple effect, maybe impact of having, let's say, higher level of nationalistic orientation than higher level of nationalistic orientation than one's country average on predicting stronger anti-immigrant sentiment. And then between effect is refers to the impact of living in a country whose mean level of nationalistic orientation is higher than overall mean of country means. And then the contextual effect might be additional impact of living in a country with higher nationalistic orientation mean above and beyond the effect of one's individual level of nationalistic orientation.
Yeah, well done.
That's great.
That's a mouthful.
But then does it, in more simpler words, does it mean that, so in some countries where like everyone is super nationalistic, in this country maybe having high national pride or close feeling to one's country doesn't predict one's anti-immigrant attitude. Although in theory it should predict that if you're nationalistic, you should be anti-immigrant. You should oppose more. You should more opposed to immigrants. But in that kind of country with higher overall super high nationalistic attitude, then the prediction might not work. Is it right?
I know where you're headed. I'm trying not to give away the answer. I was going to let you tackle it.
Are you talking about like differences like random slopes or?
Yeah, I think that's
Yeah.
what you said.
I wasn't sure, we can go into that, but I was thinking like if you were talking about, like the effect of being in a country that's like really high or really low, and that like, yeah, if the country's a lot higher, then maybe they'll have like, you know, the impact on it, but then with the within part, I think what you're asking, if I'm correct, of like if a person within a country is higher than their average, so like even if the average is super high, there can be people that are still like above that average or below it, hopefully. Yeah, and then, you know, once we go into the different slopes, that you're giving the same slope for the predictor to all of the different countries, but then that could vary across countries, and you could give each country its own individual slope for the predictor, and that is uniform.
That's uniform, in progress. Or,
Yes.
In progress for me.
Yes.
The slides are up, the example is still being fussed with.
So there's more ways that it can vary across, whereas right now we're having the same slope for that predictor. Yeah. No. I understand. You have, each cluster has their own mean, but then the slope itself is going to be the same, whereas, like in this case, whereas when we go into random slopes, you're going to have each cluster have its own mean, but then you can have the predictor's slope have its own slope based off of what country it's in. It takes a while to process, so yeah, it's still time to get to that. Yeah. Any other questions or comments?
Nice job.
Okay. Yeah, my last one was just students in school, but I think you're all familiar with that based off the examples. Yeah. Thank you.
Can I draw you a picture that would help answer maybe your question?
Yeah.
Can I draw you a picture?
Yeah, picture.
I gotta get paint out.
Well, you could just draw on the Erica slide, or make a new slide, and use the draw tool from there.
No, I'm gonna draw with my mouse.
Okay.
Okay, here's my y-axis, here's my x-axis. This is some kind of anti-something, right?
Just put A for anti.
Or higher scores mean worse? Okay, here's my scientific axis, right? So in this case, the stronger your anti-attitude, the more likely you are to have another kind of anti-attitude. Can you give me the words again? If you are more nationalistic, you will be more anti-immigration. Okay, so nationalistic is not necessarily a bad thing, or is it?
Not necessarily bad, it's just a trait.
Okay, well then we won't put happy faces for that. We'll just say big N here for nationalistic and little n for a little bit nationalistic. Okay, all right. So where we are right now is we have assumed that all clusters, as Erica said, has the same slope. So the effect of being more nationalistic than others in your country is the same for all countries. Okay, so the idea of a random slope, hang on here, is that you would have different amounts. So maybe in some countries there's a weaker relationship, in some countries there's a stronger relationship, maybe there's even a negative relationship in some countries, so it spans. So essentially what we would have is like a mean slope in the same way that the intercept is the mean of the cluster means. And we have different deviations of how much more positive or more or less positive your slopes are relative to that mean slope. So each country, is that the end of your story? Okay, each country can have its own effect of nationalism of its people. Now, what I think you are talking about is actually what I would call an intra-variable interaction. A cross-level interaction, make my big N again here. So did you think that in countries where there is more average nationalism, would they be more susceptible to individual differences or less? So in countries where there is a higher average amount of nationalism, does it matter more or matter less what an individual does?
Yes.
Less? Okay. So then this would be like a country that has a big average N. And then this would be something like a country that has a small average N. That's an N, I swear. So essentially then you would have the amount of nationalism as a moderator for the effect of having relatively more of a person. So maybe there's bigger differences in countries where it's not as prominent, but fewer differences in countries where it's way more prominent. Yeah? Yeah. I can give you an analogy with stress and coping. So if you're like, let's say I'm going to pick on somebody, like a 10-year-old, whose biggest problem in life is that we only let him have YouTube for an hour a day, then everything becomes a big deal. And like there's a reactivity to small increases in stress that are, I would say, disproportionate at times to how much stress this actually is. Whereas you look at, say, the 10-year-old's parents who are juggling a lot of stressors right now, and it's like, oh, what's one more? I'm fine, right? Just let's keep piling on. So the effect of one more stressor in the parents is maybe not as strong as the effect of one more stressor in the kid. How much you get stressed out might depend on how much absolute stress you have.
That sounds like a new homework problem.
It could be, but that's more of a longitudinal example. But yes, essentially you can have the within part of a variable and the between part of the same variable interact, so that the effect of being more than your cluster depends on how much your cluster has. And the precursor to that would be the idea that each cluster needs a different slope in the first place, and then clusters differ from each other in that way, in addition to their mean differences, and we can have interactions that explain why those slopes differ across the clusters. That's Unit 4. That's where we're headed. Random slopes and cross-level interactions are a whole thing.
We're random sloping straight lines, not random sloping parabolas or things of that nature.
Oh, no. Straight lines only in this class.
I was giving myself a headache when I was thinking parabola.
Yeah, it does turn out that the key to unsmushing a cross-level interaction is a parabola term, but that's like 50 slides from now, so I'm not going to go there just yet.
Okay.
Okay, other questions or things that you want to talk about? Folks who wrote questions down as their answers, do you feel like you've gotten what you need, or do you want to ask about anything else? No? If you change your mind, let us know. Thank you for the slides. Erica, do you want me to put these up on the website? Do you care? Do we want these on the website, folks?
I think those
That'd be
would be
helpful.
that'd be great.
Why not, right? Err on the side of posting stuff is what I would probably say. I think I want to go back into example 3, because I feel like having numbers makes things a little more concrete, since we just talked about a lot of concepts and words. Yes, big nods? Okay. So in this example, this will be the last one with this particular data set. So kids in schools, level 1 within level 2, we are predicting math, this one I think?
I think so.
That sounds right. Yeah,
There's
math in this one.
math with reading and stuff.
Yep.
Or it's also,
So in the example 2, we did the unconditional part, meaning fitting an empty means random intercept model, ICC1 for the amount of variance that is between clusters on average, ICC2 for the reliability of that cluster mean, random intercept confidence intervals to try and describe the range of variability of the cluster means, and you had level 2 predictors in your homework. Now we're adding in level 3 things. So do you want to go back over any of the correlation stuff and creation of the variables, centering and all of that? Or do we feel okay with that? Mostly okay? Thumb check? Okay or not okay? Okay, well if you're not okay, you can always rewatch the videos too. That's the other thing, is that I've explained it at least once somewhere, and your TAs are happy to explain it to you as well. So the main thing that I had wanted you to take away is that if you just print a bivariate Pearson correlation matrix among your variables as one normally would in a typical regression type model, those correlations are smushed because they represent the relationships among the level 1 within cluster components of the variables, smushed with the level 2 between cluster components as well. So you would want to report level-specific correlations if at all possible. We did an empty model here. ICC is 0.18. So that means that any level 2 predictors at most can explain 18% of the variance in this outcome. Level 1 predictors then can potentially tackle the other 82%. Yay, math. So we looked at a model that had a cluster mean centered SES as a quantitative predictor. We also, I don't think you haven't got the other predictor yet. So SES has an intra-class correlation of 0.63, so that definitely means we've got between cluster variation to contend with in there. The other predictor of, I think it was non-white status, binary, has 62% cluster differences, so there's going to have the same story. So we added in cluster mean centered SES. So that is the original level 1 variable minus the mean across the rows for that cluster that we had to ask the software to compute. This is something you have to do yourself, and there is code to do so in all the packages. That within slope then is 2.19. So for every additional unit of SES more than the rest of your school, your math goes up by 2.19 relative to the rest of your school. So this is purely like if I only sampled one school, this is the relationship that I would be talking about within a school relative to your peer group. And which of my 2 variance components should that new slope have explained? This is a within cluster level 1 person predictor. Therefore, it should have explained level 1 within person math differences. Yep. So within level 1 intra versus between level 2 inter. And indeed it did. So the little function that I created, what the residual variance was from the NP model minus what it is now, divided by what it was, gives me this proportion. So 5% of all the student differences in math have to do with student differences in SES. And as Erica had stated, the random intercept, pseudo R-square, is a little bit negative. That means the random intercept variance went up. It has to, at least to a small extent, whenever you explain level 1 residual variance, because there's less of a correction factor that is subtracted off to form what it thinks the true between groups variance is. So when you see this, know this is a logical consequence of including a pure level 1 predictor in a multi-level model. More generally, this is going to happen. We then added the cluster mean. So this, to me, if you don't include it, is weird but not wrong. I think it's natural if you have the level 1 variance in a predictor to want to describe the level 2 version as well. Otherwise, it's like you're saying the effect of having more SES than your school, but what your school has isn't part of the story, and so that's what makes it weird to me. But if you don't have a reason to put it in, or if you put it in and it's 0, then I think it's a reasonable thing to take it out and just have a fixed effect at level 1 instead. So under cluster mean centering, you don't have to worry about smushing. That's where I'm headed with this. So if I add in this new level 2 predictor, school mean SES, which has been left uncentered because 0 is already the mean of the variable, then note my within slope is exactly the same, 2.19. That's because these stay in their lanes. So I've added a between school relationship that is 5.87. So for every additional unit average SES for that school, that whole school's math goes up by 5.86. And which variance component should this level 2 school thing have explained?
Level 2.
Level 2 school thing, yes, the answer is in the question. Random intercept variance at level 2 is what this should have targeted, and indeed it did. So I have pseudo R-square for the intercept relative to the empty model is up to 0.69, and that all came from this model, adding that there. Random residual variance, did not change. And I think that's where we left off last time we visited this handout. Does that sound right? Okay, are we ready to move on, or is there anything we want to talk about first? Is that ready as we're gonna be?
Mm-hmm.
Like, I'm resigned to this.
I have a question.
Yeah, please.
So if you can go back to the result, like the within cluster and then
The coefficients table,
yes.
right here.
Yeah, that.
Mhm.
So for the first result, and then you use the score difference, then there is a 5.86, and due to each individual difference is 2.19.
Mhm.
But how do I know if I got affected by both? So that's 7.9 something, right?
Ah, yeah, the, like, the net change, like, yes, you could be affected by both. If relative to the reference school, your school had 1 unit more average SES, then you'd be bumped up by the 5.86. And within your school, if you had 1 unit more SES than someone else, then you get bumped up by the 2.
Yes. But how, yes, so in that case, the individual student in that school, and then also because of its own difference.
Yeah, the net change would be like the full 7 or almost 8 that those two coefficients together would be. Yep. All right, you ready to see what would happen if we just use grand mean centered level 1 SES instead? So this was one of your questions on your formative assessment. To be a little more concrete, we're just putting in SES at level 1 only. We are centering it at 0 because 0 already means the grand mean of the variable, and we're not putting anything in at level 2. All right, so what's going to happen? Let's form some intuition about this. What kind of information is in this SES variable, level 1, level 2, or both?
Both.
Both. If I had subtracted like 3, would that change that?
No.
Nope. That's why constant centering is just changing the reference of the intercept. It doesn't change the information, and therefore it doesn't change the interpretations. So if this is both kinds of variance in the predictor, and we just saw that SES matters at the student level and at the school level, 2 and 5 something respectively. Which variance is this going to account for? Is it going to reduce level 1 people variance, level 2 school variance, or both? Both.
Because you're measuring both. Right?
So we know from the last model what the right answer is, so to speak, for what these effects are. We know that the level 1 within slope should be 2.19. We know that the level 2 between slope should be 5.87. And we know that those two slopes accounted for about 5% and about 69% of the variance at level 1 and level 2 respectively. We know that. Now let's see what we get out of the smushed model. So stated folks, I condensed all of this, but this is the same process. I am fitting the model, saving the results, using the empty model results to compute pseudo R-squares, and then computing a total R-square as well. R folks, I've walked through the solution in this case. So we have now, I've copied in what we know is the right answer from the model where the effects are split across levels to what we get from the current model. So intercept of 12.65 versus 12.68.
Reasonably close.
Fine. I'm fine with it,
0.03.
right? Exactly. I can live with that. Now, student slope of SES of 2.39 versus 2.19. It's a little different. It's not that different, though. Now, if we think about this slope being smushed, right, because that's what it is, it's the 5.87 smushed into the 2.19, but it's not an even smush. It's more like here's 1 and here's 2, and the smush is like that. That's because how many students do we have?
Lots.
Like 7,000 or something? How many schools do we have?
160.
160. So yeah, in terms of the weighting, it's much closer to the level 1 effect. And so I think that folks who don't get as upset about this as I do would point to this and be like, it's 2.19 versus 2.39, I can live with that. Well, what are the downstream consequences? Let's look at the R-square for the model. The right answer, over here in the box, we should have explained, this is not the right answer, this is the one from just the within only version. So we explained 5% of the level 1 variance in that model. We explained just about the same here. Now, do you remember what the level 2 variance R square should have been in the right answer model? Like 0.68 or 0.69, somewhere in there. In the smush model, it's 0.45. In other words, the real between school effect of SES should have explained about 70% of all the reasons schools have mean differences in math. The smushed model only explains 45%. Now, if you talk about 70% versus 45%, does that sound like a big deal to you?
That's huge.
I kind of think it should be, yeah. So the problem with smushing is not what happens at level 1. The slope is going to be reasonably close in most designs. The R square from that slope for the level 1 residual people variance is going to be reasonably close to what it's supposed to be. It's the level 2 model that is screwed up. It's not getting its full between level effect. According to this smushed model, what does it say the between slope is going to be?
0.2?
Not 0.2.
Oh,
Let me make it bigger.
what between, sorry.
Yeah, what does this model that we're looking at right here with the smush slope say the between school effective SES is supposed to be?
0. Well,
Not 0. What's the definition of a smushed effect? Let's go back to that.
It's a weighted average.
It's a weighted average, but what's the assumption that's being made?
There's a level 1 predictor that has both two slopes, one level 1, one level 2, and you're just considering level
We're saying that they're the same.
Mm.
We're saying that they're the same. So this is, let me back up to my smush picture, this picture. We're saying that the green level 2 part has the same fixed slope at level 2 as the purple level 1 part. That's the smush slope. So what this model is saying the between slope is 2.39. It's supposed to be 5. And that's why the smush model only accounts for 45% of the level 2 variance, whereas the correct model accounts for 70%. It's because 2.3 is not 5.8. But if we think about the downstream consequences of it, well, I just care about the students. Why should I worry about this? Oh, but you want to have a properly specified model, right? So you can make correct inferences about your students, and you're willing to screw up your school part? Would not recommend. 1 out of 10. So within
and
is
also,
2.2.
if you do that, you're saying there's no contextual effect.
That's right. That's another way to say it. Exactly. So if it's okay that 2.39 does the work of 2 different variables, that you need one slope and it's 2.39 at the between level and at the within level, then you are saying that there is no contextual effect, meaning that 2 and 5.8 are close enough, you can just put them together.
So if that were the case, and let's say that you had like a 1 unit of within and a 1 unit of the school difference, would you have to use 2 in for your X or 1 in for your X?
It's still 1 unit, but X is on a different scale.
Okay.
So there's a weirdness here.
Okay, so it's a weird.
It is weird.
Okay.
But the contextual effect in this model is between 5.8 minus within 2.2. So what is that?
3.7.
Yeah, don't make me do math in front of you.
3.7 is close enough.
Yeah, 3.7 something, right?
Yeah.
So we will get that number in just a moment. But I already had it because up in the cluster mean centered model where both pieces are in here, I asked for it. So I skipped over that part. Let me go back to it. If you do cluster mean centering and you care about the contextual effect, you can still get it. It is, in this case, this is within times minus 1 plus between times 1. And there's my 3.67. My 3.67 is significantly greater than 0, according to my p-value. So yeah, there is a contextual effect. That means that these two numbers are not the same. That means it does matter what school you go to with respect to your SES, even after you control for your SES. So the way that we fix the smushed effect is to do what?
Level 2.
We
Or
add,
add a level 2, sorry.
we gotta add the cluster mean back at level 2.
Mhm.
So in terms of parameterization, I would refer to this as a within contextual model because that's what you get back. At level 1, even though my level 1 predictor still has both levels of stuff in it, we've controlled for the level 2 part by adding in the cluster mean. Therefore, the unique effect at level 1 is just reflecting its within contribution, and it's the same as what it was in the other model. So the output then, after adding in the cluster mean, we get back, let me see if I can, there we go, we can see it. These 3 numbers versus these 3 numbers. The cluster mean centered model returns a within cluster effect and a between cluster effect. The constant centered version of the same model returns now a within effect, so 2.19 in both spots, even though the variable that it multiplies is different. And at level 2, even though it's CM SES in both places, it has a different interpretation.
It's contextual.
Mhm. So this between slope of 5.87 is the effect of school SES, period, without controlling for anything about the students, whereas this contextual SES effect at level 2 is the extra contribution of the school after controlling for the students.
How do we know which model is better?
They are likelihood equivalent. There is no better. Because either model at this point is going to give you the within slope at level 1. The cluster mean centered model will give you the between slope at level 2, whereas the constant centered model will give you the contextual slope at level 2. But between minus within is contextual, within plus contextual is between. So you can get across.
Okay. And didn't you say that the second one we just looked at just now
Mhm.
is more often used, but it's also used incorrectly?
That's right. Yes, I would say that constant centering is still the modal thing that I see in cluster data analyses, but it is easier to screw up. As you just saw, if I only put in the level 1 slope, I get a smushed effect. If I only put in level 2, I would get between. When I pair them together, I get within and contextual. So you have to know what you're doing.
So in Lisa language of labeling,
Mm-hmm.
would it be, for your purpose, I understand why you had CM, SES for both.
Yes.
But if you were to do the other, would you maybe use like CONT or something like that in front of the SES for contextual?
I used to do that.
That's what I'm saying. I could see that from.
Yeah, about circa 10 years ago, I would have, like, it would be something like, I didn't teach cluster data, so it would be people, it'd be like BP and WP within
Yeah.
person. This is like BM instead of CM, which is, exactly, like, my 10-year-old would have thought that was hilarious, but I'm not gonna go there. No, so I stopped doing that because when we get to the point where this variable and this variable are the same thing, but what they mean is based on the context of the model. And so then they're the cluster mean, and I just stopped trying to label it based on interpretation because it really doesn't stay constant.
Okay.
Yeah, I used to do it that way, and I got hit. So which variance then do you think this new cluster mean SES is going to explain? Level 1 people variance, level 2 cluster variance.
I'm gonna guess level 2.
Yeah, cluster mean SES, is that a cluster thing or a people thing?
Cluster.
Cluster thing, does it explain cluster variance or people variance?
Cluster.
Cluster, yeah, don't think too hard. Like at this point, like it is as you would think. It gets a little tricky later, but that's not today. A little trickier, I should say. So yeah, you're right. So what if I wanted the between slope out of this model? Linear combination. Within plus contextual equals between. So addition then gives me the 5.87 that the other model would have given me directly. In terms of an increase, We went from R square of 0.45 in the smushed model,
Which is terrible.
unsmushing it by picking up the cluster mean, added another 24% to that tally, bringing us back up to what it was supposed to be.
And the other was unchanged as expected.
Unchanged to 4
Or
decimal
it-
places, but yeah, it's gonna wiggle a
Relatively,
little.
but
Yeah, yeah, because we didn't change the information at level 1, it was already still in the model. We just changed what level 2 information was in the model. Yep. So in terms of thinking about like what sources of variance are explaining what, at level 1, it's the within effect. That's the only possible answer. To the extent that some students have higher SES, that is responsible for 5% of the student differences in math. Boom. Now these two numbers, this is the tricky part. Actually, these two. Let's highlight all three.
Ooh.
The full answer, is that due to the contextual effect or the between effect? In terms of the full amount of variance explained for the intercept.
Between.
It's between or contextual. This is a tricky one. Cough, cough, homework question.
I'll go with Gus too. Go. Between.
Okay, we got one vote for each.
Between.
Okay, another vote for between. 50-50 shot.
That's right.
I would say that this relative to 0 is because of the between effect. I would. But you already had your submitter's remorse. I will allow you to send me an email.
So would you
And
consider
then,
the 24% contextual?
I would. Getting it up to what it should be from where the smush model left off, that's contextual. Because if the smush model were okay, what would this change be? 0, exactly. There is no contextual effect. All I need to know is how much money this kid has. I don't need to know anything about the school, and I can predict their score. I have a picture.
Ooh.
Okay. Skipping ahead. This is slide 32. This is a generic drawing of a lack of a contextual effect and a contextual effect. So this is from one of my papers on the topic. So at level 1 then, if we have the original level 1 predictor and we condition on a particular value. So for a student who has a 0 on this variable, like SES, one more unit, right, within schools translates into a higher outcome. Like the slope of these individual school-specific lines is positive, but the differences between them are minimal. And so at this point, there's a contextual effect of 0.2 in the graph, meaning that you get a little bit of a bump if you go to a school that has a higher mean, but not very much. So this is where the term convergence comes from for this as well. That's another one. So there's a smushed, conflated convergence, like these separate trajectories, if you will, that describe each cluster's relationship are all converging onto one line. So to the extent that a smushed effect is okay, you can draw one line through all three of these lines, and it's fine. The bottom slide, or the panel here, illustrates the opposite. So this is where we have 0 between effect, so the line through the means here is flat. It does not matter what your school is like. Within a school, if I am higher than the other kids in my school, my score goes up by 1. However, after I condition on a 0 for that kid, kids who go to schools that are lower are actually predicted to do higher. The contextual effect is negative. So this is a situation in which you would have to be very, very careful about how you talk about this. Do schools matter? Yeah, no, they don't. The screen school effect is 0. Do they matter after controlling for student status? Yes, they do. So contextual is after controlling for the effect of the student, and the same variable between is before controlling. We will have lots of pictures sort of like this in the coming examples to try to help sort this out, because it does get tricky. And all of these slopes are parallel, right?
In this situation,
Looks like.
Consequence or coincidence? Consequence. Yeah, these pictures are not depicting any kind of interaction terms. The paint drawing that I made a little while ago was trying to depict interaction terms in different slopes. Now you can see why I make PowerPoints instead. I'm not good at art, sue me.
you can use the board in here though.
I can't use the board and have it be captured on the recording. That's the problem. So I've trained myself to sit and not wander around and to not do anything that's not on my laptop. But that is the price we pay.
You need a wandering podium is what you need.
Nah, I'm just gonna sit here. I'm good with
Okay.
sitting.
Okay.
All right, 143, folks. Questions before we adjourn? Okay, so let's do a little end of class repetition. Between minus within is what?
Contextual.
Contextual. Within plus contextual is?
Between.
Between. If I cluster mean center, my variables stay in their lanes. If I grand mean center, there's a risk of smushing until I add the cluster mean back in. And then the cluster mean helps steer it back into its lane where it's supposed to go. Just like mommy.
Mm-hmm.
Okay. Woo. All right, then keep making progress on your homework. Let the TAs help you on Thursday if you wish. Otherwise, take the day off. And I will see you on the other side. I do have office hours tomorrow if anyone wants to come stop by. Okay? All right, happy garbage day, everyone. Thank you for being here. Peace out.